Assalamualaikum and very good morning to all of you. Before we continue our lesson about chapter 3, it is about force. Let's recap our previous lesson before this. Okay, it is about linear motion, our second chapter. First, you learn how to define linear motion, uniform motion, and also non-uniform motion. Meaning that you have to know the definition of linear motion, uniform motion, and non-uniform motion, and the example between them. After that, you learn about distance and displacement, speed and velocity, average velocity, acceleration, and also deceleration. And then you should know how to apply the concept of linear motion in solving the related problem by using formula. There is 4 linear motion equation that you have to remember. There is V equal to U plus AT, V square equal to U square plus 2AS, S equal to 1 over 2 U plus V times T, and S equal to UT plus half AT square. Okay, again, U is for initial velocity, represent for initial velocity, V is represent for the final velocity, A is for acceleration, T is for time, and S is for distance and displacement. Right, so this one you have to remember. And you should know how to illustrate velocity against time graph. Velocity against time graph. From the velocity against time graph, you can find the velocity. You can find 3 things. There is velocity by looking at the graph, and then you can find the displacement by calculating area under the graph, and you also can find the acceleration by finding the gradient of the graph. Okay. And then you should know how to determine the velocity, acceleration, and displacement from the graph. Okay, I hope that you don't have any problem about this chapter. Okay, if you still not understand, you can come and see me at my office. Clear? Alright. Our third chapter, it is about force. Okay, what do you understand about force? Can push and pull? Is there any example that you can give me about force? Okay, let's say in your daily life. Is there any force that you use in your daily life? Right now, is there any force you use? Yes. Okay, so actually you may know about the force every life movement by reading books, by talking, by running, writing, standing. Okay, all they cause object to move or stationary or stay stationary. That one we call force. All right. Actually, we have 2 types of force. I will explain to you after this. Okay. Okay. Look at this diagram. Man standing illustrate gravitational force. So right here, actually we have force. How many force we have? Actually, two force we have. There is gravity push down on the person, and the floor push upward on the person. So by standing on the floor, it still have force. Alright? Okay, here I give you some common example for force which you see in your everyday life, which you can go through. Okay, for example, a football is kicked harder and it moves faster. Later, after some time, its force decreased due to friction. So next, a moving bike stops when brakes are applied. So this is some kind of force. And attractive force between the bodies and universe. attractive force between the bodies in universe, right? And then gravitational force acting the ball moving up. Okay, gravitational force is downward, so if the ball moving up, there is a attracting gravitational attracting force, right? And a bull is pulling the cart due the force. This example of force in many more in your daily life is two team of players are pulling with enough force the rope in a tug of war game. A man pulled the door of the room. A boy put a drawing paper by inserting a board pin with it on the notice board. Squeezing of the wet clothes to make it dry. Also, we used force right there. A glass rod is rubbed with a sieve so that it attracts the tiny part of the paper toward itself, and it is the example of action at distance force, right? You rub the glass rod and then with the sieve so it will attract the tiny parts of the paper. Okay, so actually there's many more force in your daily life. If the question asks you to state the example that you use in your daily life, you can state your own example, right? This is some example for you to understand. Okay, about this topic, at the end of this topic you should be able to define force and its unit, state the effect of force. Example of force and effect of force is different thing, yeah? Don't get confused. I will explain it after this. And you should know the differences between weight and mass. Weight and mass, sometimes students confuse. It looks like same, but it is not same. I will explain it to you after this. And then you should know how to define Newton's second law. As I told you before this, actually we have 3 Newton's law, but in this course we will focus more on the Newton's second law only. Alright, and you should know how to define force in equilibrium. After that, you should know how to calculate resultant force and resolution by using the resolution method. So you should know what is the resultant force and what is the resolution force, and how to combine them to solve the problem by using the resolution method. Okay, and then apply the concept of force in solving problems related to equilibrium of forces. Define moment of force and its unit. So moment is something new for you. I will teach you after this. And you should know how to apply the concept and formula at moment of force in solving the related problems. Okay, so in this chapter for force, this one that you have to cover up. Okay, alright, firstly you should know the concept of force. Before we go through one by one, you should know the concept of force and its unit. You should know what is force and its unit. You should know balance force on the object. What is balance force on the object? Make sure you also know what is unbalanced force on an object. The difference between balanced and unbalanced force on an object, right? You should know effect of force on object, effect of force, not example of force. You also should know the differences between weight and mass. What is weight? What is mass? And then we will focus more on the Newton's second law. There is F equal to ma, force in equilibrium, and simple breakdown of force, right? Okay, force and its unit. Actually, force can be defined as a push or a pull. This one you have to highlight and remember. Again, force can be defined as a push or a pull. Okay, A force will cause an object with mass to accelerate. Force is measured by Newton, because Mr. Newton, I said, that found this concept, right? And a force is a vector quantity. Why it is a vector quantity? Because in force we have magnitude and also the direction. You have to consider the direction, okay? Meaning that we have axis, y, and also x. Right here must be in positive, upward also positive, downward is negative, and right here you have to put negative. So direction in chapter force is so important, okay? Don't eliminate it. And then a Newton meter is used to measure force. Newton meter is used to measure force. Okay, this is example for push and pull for definition for force that you have to remember, right? Okay, two main type of forces that you have to understand. We have contact force and we have non-contact force. So what is contact force? Contact force are forces that result when two objects are physically in contact with one another. For example, push, pull, normal force, friction, spring force, tension, and air resistance. That one we call contact force. Okay, what about non-contact force? Non-contact force that result when two objects are not in physical contact. You know what is physical contact? Okay. Example, gravitational force, nuclear force, magnetic force, electrostatic force, or we call it as electric charge. Okay, two differences between force. There is contact force and non-contact force. Then we go to the balance force on an object. So balance force, what is balance force? When all the force acting on the object are balanced, they cancel out one another, and the net of the resultant force is zero. So the object behaves as if there is no force acting on it. Okay, resultant force in Malay we call it as paduan daya, right? Therefore, a stationary object will remain stationary and moving object will continue moving with the same velocity in a straight line. Right? Stationary object will remain stationary and a moving object will continue moving without with the same velocity in a straight line. So this one we call it as balance force. So, can you give me example of balance force? Okay, what is example of balance force? A balance force is one in which net force equal to zero. Okay, right here, a diagram right here, do you think there will be any motion? No, because this person pulled in 25 Newton and the next person pulled with 25 newtons. So there is no movement, so we call it as a balance force. Same like this. Okay, there's no movement, we call it as a balance force. Okay, how about unbalanced force? When the object acting on object are not balanced, there will be net force acting on it. Okay, this net force is known as unbalanced force or resultant force. Unbalanced force normally cause stationary object to move or moving object to accelerate. This one you have to understand. Okay, again, for unbalanced force case, can cause stationary object to move, or moving object to accelerate. Can you get it or not? Okay. For example, when a football player kicks a stationary football, of force on a ball and cause it to move forward. So this is this diagram shows balanced force and unbalanced force. For the first diagram, 300 Newton, 300 Newton. So 300 Newton. The direction is negative 300. Actually, we have to add together because right here is negative, so you have to put negative. Actually, like this, yeah. 300 Newton negative for the 3% right there, plus, and 300 right here, the direction is right here, 300 Newton. So 300 and 300, you will get 0 Newton. So 0 Newton, we call it as a balance force. How about the next diagram? So 400 Newton, 400 Newton, the direction is over there, is negative, so you have to put negative 400 Newton plus 300 Newton. So you will get negative 100. So for this diagram, it will go to over there. It's negative. Okay. Okay. Balance force, again, for equal force that act on object from opposite side, the object doesn't move. And for unbalanced force, unequal force that act on the object from opposite side but make the object move. So we call it unbalanced. I hope you understand what is balanced force, what is unbalanced force before we continue more deeper. Okay. Okay, right here, example. These two objects are equilibrium since the force are balanced. How you check this force is equilibrium? For this case, you can simplify. Total for Fx is equal 30 Newton negative plus positive 30 Newton. So you will get 0 Newton. Total Fy is, for upward case, is positive 50 Newton plus for downward case is negative 15 Newton. So we will get 0 Newton. So we call it as balanced or unbalanced force, balanced force. So this case, it will be in stationary. How about for this diagram? It is balanced or unbalanced?
Unbalanced.
Unbalanced. Because 100, negative 100 plus
85.
positive 85, so you should get negative 50. Okay, how about this diagram? You have to simplify total Fx and you have to calculate for total Fy. Okay? So total Fx right here is Fx is Fx is positive 50 Newton. Fy is
positive 35.
Are you sure positive?
Negative
Negative
35.
negative
25.
25. So it will go to downward case. This is example for unbalanced force. Alright, this also unbalanced force. Okay, 100, 1200 minus 800, positive. 600 minus 8, you will get negative 200 Newton. And for this case, you have to simplify with Fx and also Fy. Okay? Okay, effect of force on an object. When object acts on the when force acts on object, the effects are on change of size, change of shape, change of stationary state, change of speed, change of direction. Okay, then weight and mass. You should know the differences between weight and mass. You can state in definition and type of quantity. Firstly, the definition for mass is quantity of matter of body, but weight is the force with which an object is attracted towards the center of Earth by the gravity. Mass is a scalar quantity because we are not considering the direction, and weight is a vector quantity. And also the unit is not same. Mass must be in kg and weight must be in Newton. And the formula also, W equal to mg. W equal to mg. W is represent for weight, m is for mass, and g is for gravity. Can you understand the differences between weight and mass? Okay.